Hello, I'm Professor Lee. Today, I invited a student, Andrew, to join me for the presentation. We continue Chapter 1, Section 1.3 and 1.4. Let's go to frequency and frequency tables. What is a frequency? It's the number of the times a value of the data occurs. A relative frequency is the ratio, can be fraction or proportion in percent, of the number of the times a value of the data occurs in the set of all outcomes to the total number of the outcomes. Relative frequencies is each frequency divided by the total number of the sample. Let's look at the example on the right side. This is a frequency table. We have data value of 2, 3, 4, 5, 6, and 7 with corresponding frequency as 3, 5, 3, 6, 2, 1. First thing we do, we need to find out what's the total number of the data included in the sample, and which is just do addition only. We add up 3 plus 5 plus 3 plus 6 plus 2 plus 1 equal to 20. Next, on to relative frequency. The relative frequency for the data value 2, we use the frequency of the data 2, which is 3 divided by total number 20. We get 0.15 or 15%. Same thing you will do for the next class. With the data value 3, we have 5 frequency. So take a 5 divided by total 20. That's give you 0.25 or 25%. And how can we get a percent? You just need to take the decimal multiplied by 100%. That's going to bring you, remove the 2 decimal digits off and become just 25 with the percent symbol. So similarly, you should be able to complete this table up to the data value 7. We have 1 divided by 20 and get the 0.05, which is 5%. And we can always double check our work by adding up all the decimals. All the decimals from the relative frequency of each class. When you're adding up 0.15, 0.25, 0.15, 0.3, 0.1, 0.05 should equal to 1.00. If you're adding up all the percent, should be 100%. Next one, cumulative relative frequency. Be careful to see the name here now. This is cumulative. That means we have to always adding the previous one with the relative frequency. So starting with the first relative frequency, which is 0.15, adding to the next one, 0.15 plus 0.25 equal 0.4. Then similarly, just bring the 0.4 adding to the 0.15, let's give it a 0.55. So continuous doing this to all other classes. To the last one, the data value 7, you should have 0.95 adding to 0.05, become the 1.00, which is 100%. Now you can try on yourself, okay? Now, let's move on to the next section. Okay, let's continue to levels of the measurements. We are still in the section 1.3. Level of the measurement is the way a set of data is measured. By the way, what are the 4 levels of the measurement?
The 4 levels are starting with nominal scale level equals the qualitative categorical, for example, categories, colors, names, and labels. Ordinal scale level is data that can be ordered. For example, excellent, good, average, fair. Interval scale level is definite ordering but has no starting point, such as temperature scales like Celsius and Fahrenheit. Ratio scale level has a 0 point and ratios can be calculated, such as exam scores. The smallest score is 0 and 80 is 4 times of 20.
Good. So on the right side, you will see there's a summary about the levels of the measurement and the comparison among them. Take a look.
Nominal. Ordinal. Interval. Ratio.
Okay. Let's move on to section 1.4, experimental design and ethics. What is experimental design?
The purpose of an experiment is to investigate the relationship between 2 variables. When changes in one variable produce changes in another, we call the first variable the explanatory variable. The affected variable is called the response variable. The different values of the explanatory variable are called treatments. Additional variables that can cloud a study are called lurking variables or confounding variables. To counter the power of suggestion, researchers set aside one treatment group as a control group. This group is given a placebo treatment. A double-blind experiment is a research design in which both the subjects and the researchers involved with the subjects are blinded.
The widespread misuse and misrepresentation of the statistical information often gives the field a bad name.
Some say that numbers don't lie, but the people who use numbers to support their claims often do.
Researchers have a responsibility to verify that the proper methods are being followed. Okay, finally, we are going to work together for example 2. Okay, so Andrew, please.
Researchers want to investigate whether taking aspirin regularly reduces the risk of heart attack. 400 men between the ages of 50 and 84 are recruited as participants. The men are divided randomly into 2 groups. One group will take aspirin and the other group will take a placebo. Each man takes 1 pill each day for 3 years, but he does not know whether he is taking aspirin or the placebo. At the end of the study, researchers count the number of men in each group who have had heart attacks.
Please identify the following for this study. A. What is the population? B. What's the sample? C. What is experimental units? D. What is explanatory variable? What is treatment? What is response variable?
Well, A. The population is men aged 50 to 84. B. The sample is the 400 men who participated. C. The experimental units are the individual men in the study. D. The explanatory variable is oral medication. E. The treatments are aspirin and a placebo. F. The response variable is whether a subject had a heart attack.
Excellent. We finish chapter 1.